Repeat सारा भी किया जा सकता है, but I think the second part was easier to do. इसमें we have a superposition of these two loads. One was the UDL, that was 2 kilonewtons per meter, and then there was superposition of triangular load on top of it. So when I said segment BC, so we took a segment somewhere here at a distance x. So shear force, there are two forces. One is the UDL, that is varying at 2 kilonewtons per meter. So the total force in this segment will be 2x. Negative sign is because it's acting vertically downward. Nothing else. So 2x. The other force is the triangular force. This is what we draw as a bigger triangle, and I said you can always use the relationship that these are similar triangles, because we took a segment somewhere here. So the ratio of the sides of this larger triangle must be equal to the ratio of the sides of this smaller triangle. So I took a larger triangle that was 2/3, and for the smaller triangle this must be equal to y/a. I said, well, what's a is here? A is this distance, that would be x minus 2. This 2 is known from between A and B, distance is 2. So when I take a segment, and this total distance is x, so this triangle distance is x minus 2. So I wrote this here, that 2/3 must be equal to y/x minus 2. So I found out y was equal to x minus 2. So this was important. And then we came back here, and we said that, okay, the total distance for this is, we have to find out the load because of this UDL that is acting here. So we said 1/2x minus 2 multiplied by 2/3 x minus 2, because this is the load for a triangular load is always equal to 1/2 base times height. So the base of this triangle is x minus 2. The height of this triangle, we just computed 2/3 x minus. So 1/2 base times height, that is the force because of any triangular load that is varying uniformly. So we computed this relationship. For the bending moment, it was easier. These are the forces that have already been computed. We need to multiply those with the so the force was there. So this force is acting somewhere at the midpoint of this whole thing. So we said this force multiplied by x/2. Then this force we know is x on the 1/3 of the distance from the larger side. So this distance was, we just have to take the 1/3 of this distance. This distance is x minus 2, so 1/3. So 1/3 of x minus 2 was the distance, and this was the force. So force multiplied by 1/3 of the distance, we ended up with this. The next thing I just discussed was how to draw the shear force and bending moment diagrams. They are not difficult. We just have to see the initial point and the end point most of the time. So for the segment BC, segment AB, I didn't discover that it was even easier. So for BC, the starting point is when x is equal to 2, and the ending point is when x is equal to 5. So between 2 and 5 is the distance. So we just have to compute the forces and x is equal to 2. So when we put x equal to 2, this becomes minus 4. This becomes 0. So at x equal to 2, the force is minus 4. Then you have to put minus the total distance x equal to 5. So you can put 5 here to minus 10. Then this will be 5 minus 2, 3, 9, 1/3, 9. So you can compute and find out that distance. Similarly, for bending moment, you put x equal to 2, and then x equal to 5, and then you can draw those diagrams. So let's stop here, and we'll be joining back in a minute. So you guys can join. We'll start the section.